Okay, now let's start. Today we are going to discuss about chemical reactions, and as we have discussed the aspects of chemical bonding, the aspects of atomic structure in the previous sessions, today we are going to focus on chemical reactions, and specifically we are going to look at only two or three aspects of chemical reactions. We are going to discuss about chemical reactions in general. What are chemical reactions? Then we'll also discuss about the aspect of chemical equations. Then lastly, the aspect of balancing chemical equations. There are several other aspects that we will discuss within this chapter. We'll also need to understand the types of chemical reactions. We'll also need to discuss about the activity series of metals or the activity series of elements, different types of reactions including aqueous reactions, precipitation reactions, neutralization reactions, other reactions like reduction and oxidation, redox reactions, heat transfer, heat changes in chemical reactions, that is the aspect of endothermic and exothermic reactions. Those are the things that we are going to cover in this unit. But for today we are going to introduce chemical reactions. We are going to talk about chemical equations and the aspect of balancing chemical equations. So let's move on to introduce the aspect of a chemical equation. I think we have been seeing chemical equations during our previous discussions, and basically from what we have been seeing, we have seen that a chemical reaction occurs when there is rearrangement of atoms in some form of a chemical reaction, and there is bond breaking, and at the same time there is bond formation. I think in part of your first assignment there was a question which requires you to elaborate what is a chemical change, and you can see that we talk of a chemical change when there is a chemical reaction, and in most cases a chemical reaction occurs when we break existing bonds so that we form new bonds. In other words, we are trying to form a new compound. So in a chemical reaction we expect that there is a new product which is formed. But of great importance, or something which is important to note, is that in a chemical reactions atoms are not going to be created or destroyed. There is no destruction of or creation of new atoms, rather they are maintained the way they are. There is only a rearrangement of those atoms. So a chemical reactions during chemical reaction there is conservation of mass. We'll discuss about this. Let me move on to show you a typical example of a chemical reaction and explain what really happens. This is a typical chemical reaction which is usually shown by means of showing the reactants and the products. As you can see from this one, we have reactants on the left hand side and the products on the right hand side. If you can check very closely, you see that we have some oxygen molecules that are in blue circle. These are O2 molecules, and we have 3 of them times 2, which gives us a total of 6 oxygen atoms. And after the reaction you can see that we have got water molecules. These are H2O molecules, and if you check closely you see that the total number of oxygen atoms is also 6. And this slide is trying to illustrate the aspect that we are not going to create or to destroy atoms. We have started with the 6 oxygen atoms and we have ended with 6 oxygen atoms. Now the oxygen atoms in the products, they are now part of water molecules. So in a chemical reaction atoms are neither created nor destroyed. This is a very important aspect And this also brings us to the aspect of balancing chemical equations. We expect that whatever we have in the left side of an equation should be the same as whatever we have in the right side of the equation, because we are not going to destroy or to create new atoms. Okay, let's move on to the next slide, in which we are going to describe about the evidence of a chemical reaction occurring. How do you get to know that there is a chemical reaction that is occurring? Okay, chemical reactions usually are associated or can be detected by different aspects. For example, we can talk of a color change. It can tell us whether a chemical reaction occur or not. There is formation of a solid, formation of a gas, or change of state, exchange of heat, that is absorption of heat or release of heat. All those things are some of the major things that we can actually use to tell whether a chemical reaction is occurring. We can also see this evidence, for example, emission of light here, color change, formation of a solid precipitate, there is evolution of gas, and there is a release or absorption of heat. Those are pieces of evidence which can tell us if a chemical reaction is really going on. Okay, moving on from there, we now move on to why do we use chemical equations. Like I have said in our previous discussion, in our previous assignment, I have given you a question in which you should try to illustrate a chemical change, and I prefer that people should use a chemical equation, but some people, they were trying, it was difficult for people to explain the aspect of a chemical reaction or the chemical change. I've seen some people trying to say when you try to burn wood, it produces carbon dioxide and water. Then they try to draw a picture of some wood that is burning. Is very difficult, but instead it's better to use, you know, that wood is made up of carbon, and that carbon is burning in oxygen to produce carbon dioxide and water. So when we use chemical equations, it's actually a shorthand way of describing a reaction. There is no need for you to draw whatever, the fire, everything. And basically, a chemical equation provides information about the reaction by making use of formulas of reactants and the products. We don't need to write the full names, we just use the formulas. We also use shorthand way of showing the physical states of the reactants and the products. We'll show you using a typical example how we can show the physical states, whether it's a solid, whether it's a liquid, whether it's a gas, or it's in aqueous phase in solution. And we can also show the relative numbers of moles of the reactants and the products. And we can also use the equation to determine the amounts of the reactants and the products that are needed for a certain chemical reaction to occur. So that's why we use chemical equations, because they are a simple way or a shorthand way of describing chemical reactions, and they are very informative. They give you the full information about a chemical reaction. Okay, here is a typical example of a chemical reaction. A chemical equation is a shorthand expression for a chemical reaction, and here we have a word equation which is actually tedious, very long, cannot give you all the information. For example, here in the word equation, we are saying aluminium combines, or aluminium reacts with ferric chloride with ferric oxide to form iron and aluminium oxide. And when we use a chemical equation, we can illustrate by just putting a L for aluminium, Fe2O3 for aluminium oxide to give us iron and aluminium oxide. Here it is important for you to get to know the information about chemical bonding, the nature of bonding, the type of bond that is formed, and the ratio of atoms that combine to form a certain compound. So from this equation we can also try to give more information using a chemical equation to be more and more precise. We can see that the reactants are shown on the left hand side, and they are separated from the products by means of an arrow. That's why you have an arrow here, and these are the reactants and these are the products. And we can also put some coefficients. That is now the aspect of balancing the equation. Coefficients are also placed in front of the substances basically to balance them, and the subscripts that you are seeing there, they are actually part of the formulas of those compounds. They should be there. Then if you look closely, there is some more other information that we can put on the equation. We can actually put reaction conditions, usually above and below the arrow. You can put some conditions of the reactions, whether it is involving heat, whether it's absorbing or releasing heat, whether you are using a catalyst, and other conditions. Then also the physical states of substances, the reactants and the products, can be shown by putting those letters in brackets. For example, if you see this S, it means that that substance is a solid, L liquid, G gas, and aqueous, it means it's in aqueous phase or in solution. So it is very simple for the chemical equations. Okay, so you realize that some symbols that can be used in these chemical equations. We can see something like this small triangle delta. It can be associated with a certain value, maybe negative 200 kilojoules or positive 200 kilojoules or positive 200 joules. This is a description of the amount of heat that has been produced or that has been absorbed. Sometimes you can see HV. It can be associated with a value, an integer, 1 HV, 2 HV, or something like that. This is associated with energy in the form of light. Then sometimes we can have a symbol to show a shock or a mechanical shock, electrical shock. There are some symbols that can also be used for that in our chemical equations. Without wasting much of our time, we need to go to the aspect of balancing chemical equations. Okay, so basically a balanced equation contains the same number of atoms on each side of the equation, that is on the reactants and the product side. And this type of an equation, it obeys the law of conservation of mass. It obeys the fact that we are not going to create or destroy any atom. Okay, so many equations are balanced by trial and error. This is very important. It's not easy to just look at an equation, then you say if I put a 2, if I put a 1, if I put a 3, it will be balanced. They are balanced by trial and error, and it must be remembered that when you are trying to balance these equations, you can change the coefficients, like the number of moles, in order to balance the equation. But it is also important to note that those subscripts that are put on the formula are not supposed to be changed. For example, when we talk of a subscript for the formula of carbon dioxide, it is CO2. The small 2 that you see on the carbon dioxide must not be changed, because the moment you change that, you are changing the formula of the compound. So we have different subscripts that we can see on chemical equations, but those subscripts in most cases, they are representing the formula of the compound. But what we have to change is the coefficient or the number which is actually put before the formula of the compound. I think we can now straight away go to a typical example of a chemical equation which is not balanced. Then we will try to balance it. Here is an equation, and we shall outline the procedure for balancing the equation. Here is an unbalanced equation between CH4 methane and oxygen. This is a combustion reaction which results in the formation of carbon dioxide and water. This reaction is not balanced, and it is important when you have your unbalanced equation to make sure that the formula for each substance is correct. So before we proceed to balancing this, you have to check that the equation has got all the substances written in their correct formulas. That is very, very important. Now let's see how we are going to balance this equation as a typical example. Okay, so the general procedure for balancing this equation is to balance by inspection. When we say to balance by inspection, you are going to count and compare each element on both sides of the equation. You start with the element that is on the first element on your left. You go to the next by inspection, by counting and comparing. So as you can see here, we have a table which is showing carbon as the first element. If you can see here, we have one carbon, and on the other side of the equation, the right side, on the product side, we also have one carbon. They are equal. That's why we put an equal sign, and we have seen that carbon is balanced. Then from there, what's next? We have to move on to the next one, which is hydrogen. If you check on the other side, we have H4, and on this other side we have H2, 4H and 2H. That's why we put a question mark here. It's not balanced. Hydrogen is not balanced. How do we balance it? We balance it by making sure that we have equal number of moles on both sides of the equation, and it means we'll have to put a 2 here. The same applies if you move on to O2. You see that we have 2 oxygen on this side, and on this side we have got 2 here plus 1 here, which is 3. It means we also have to balance the oxygen. Okay, so in the next slide we are going to show how to balance this equation. Okay, so balance are elements that appear only in one substance first. Okay, so in this case the first part is to balance the carbon and also to balance the hydrogen by putting a 2. So 4H present on each side, it means it's balanced in terms of hydrogen, balanced in terms of carbon. But now in terms of oxygen, it's not balanced, because the other side we have 2 oxygen, and the other side now we have 2 plus 2, which is 4 oxygen atoms. So we will need to balance that oxygen. So in the next slide here, you see that when we have to balance oxygen. How do you balance oxygen? We make sure that we put a 2 here, so that we have 4 this side, and we also have 2 plus 2, which is also 4. So 4 oxygen present on each side, and finally our equation is balanced. This one here is not necessary. We can put it, we might not need to put it. It is not necessary. So this is basically how you balance these chemical equations. In the next slide, I'm going to give you some unbalanced chemical equations. Then we are going to try to balance them. We are going to try to balance some chemical equations. Okay, here are the 3 chemical equations that we have. In your chat box, I want you to try. Okay, we can try together the first one, then you guys will try the second and the third one. So we are going to try the first one, which is sodium plus. Okay, let me write the equation here on the chat box. I hope and believe you guys are seeing. We have sodium plus sulfur. We have sodium plus sulfur here. I'm trying to put the arrow. Unfortunately, sodium plus sulfur, we are going to get sodium. We can't put the subscripts. So basically our equation is like this, and as you can see, we have one sodium on the reactants and we have two sodium atoms on the product, which means sodium is not balanced. It means we have to put a 2 here. We put a 2. Then let's move on to sulfur. We have one sulfur and we have one sulfur. It means now our equation is balanced. So this is the balanced equation for the first equation. So I want you to attempt the other two equations, but because of our time, you can do that later on after our discussion. So for now, allow me to proceed to some other examples of balancing chemical equations. And if you can check, I want you also to attempt these examples. They have some answers, and I want you to also attempt on the other slide. You will see more examples of chemical equations. They are not balanced. You try to balance them also after the discussion. If you have any challenges, we can also discuss that. Allow me to move on to another type of reaction which we need to understand how to balance, and this type of a reaction is called a redox reaction, reduction and oxidation reactions. So usually for reduction and oxidation reactions, or that were the types of reactions that we call redox reactions, there are some steps that we should follow when we try to balance the redox reactions. In some cases, these redox reactions are given as half reactions. So when you're balancing redox reactions, there are some steps. Step one is to balance other atoms excluding hydrogen and oxygen. You start by balancing some other atoms. You'll see in one of the examples that we are going to try. Then the step two is for you to balance oxygen atoms. How do you balance oxygen? You realize that there are some equations, the ones that we call the redox equations. You realize that you can have oxygen on one side and you don't have oxygen on the other side, and it will be difficult for you. How do you balance the oxygen? For you to balance oxygen atoms in redox reactions, you add water molecules. You have to add H2O to the side that needs more oxygen, or the side that does not have oxygen. You put H2O, which means your oxygen will be coming from the H2O. Then you realize that in those redox reactions, you can have a situation whereby one side has got hydrogen. It might have maybe water, and the other side does not even have any hydrogen. So for you to balance hydrogen atoms, you have to add H plus ions. You add H plus to the side that needs hydrogen, or to the side that does not have hydrogen. Then besides that, for these redox reactions, it is important because they will involve some charges. They usually involve some charged species. It is important for you to balance the charges. How do you balance the charges? You check on the charges, the total charges, and to balance the charges, you will need to add electrons to the side which is more positive, so that the charges become balanced. And the step 5 is to make sure that you equalize the number of electrons or the charges that are on both sides by multiplying one or both half reactions by an integer, so that the number of electrons lost and the number of electrons gained is equal. I think this is actually simple, and we will try to attempt an example to illustrate this. Okay, let me see if we have one example here. Okay. Okay, examples: balance the following redox reactions. I think as you can see on the list we have got 1, 2, 3, 4 redox reactions that needs to be balanced. So for these redox reactions, maybe I'll try to attempt which one. Okay, we can try to attempt the first two. Okay, because I understand that these ones might be a bit challenging. So let's go to our chat box and we are going to balance the first one and the second one. They are not balanced, and unfortunately I'm not going to include the state symbols. So the first one is Al for aluminium plus copper 2 plus. I'm going to put copper 2 plus, copper 2 plus. Let's show that this is a charge. Let's try to put the arrow. Let me pick it from here. Then we are going to get a L3 plus, a L3 plus copper. I hope you guys are seeing the equation. I've tried to write the equation that we have on the first example on the chat box. Unfortunately, these are types of questions that we might need to use to illustrate in person using maybe a whiteboard, but we can just try to explain we can try to explain it in the most appropriate way. So like I said, when you are trying to balance redox reaction, the first aspect is to balance off other atoms that are not oxygen, that are not hydrogen. So in this case, if you check on this equation, aluminium is 1 and aluminium is 1. This is a charge 3 plus. It's not you can't balance off the charge by putting the superscripts or the subscripts or anything else. So it is okay for aluminium. And for copper, we have copper 2 plus, which is just 1 copper versus copper on this side. It is balanced. It means in terms of the atoms, it is balanced. But remember, we say we balance the oxygen, we also balance the hydrogen. There is no oxygen, there is no hydrogen. So in terms of those elements, it is balanced. Then from there now we have to balance the charges. We have to balance the charges. How do we balance the charges? We check the charges on the left side. Here there is no charge on aluminium. On copper there is 2 plus, which means this side the total charge is 2 plus. On this side there is 3 plus, and this side there is 3 plus plus 0, which is 3. So the total charge is 3. 3 versus 2. It means the charges are not balanced. The charges are not balanced. Okay. How do we balance the charges? It means we have to add electrons on the side which is not balanced. Here we put an electron like this. If we check this equation now, 0 charge plus 2, this is 2. Here 3 plus 0 plus negative 1, the charge is 2. So the charge is now 2 versus 2. It means this equation is now balanced. I think this equation is now balanced. There's another way of balancing this equation using half reactions. We'll discuss about that one next time, but for now let's move on to the next equation. Cl2, that is chlorine, it is going to give us ClO3 minus plus Cl minus. Okay, you can see this is our second equation. I think you can clearly see this. And the first aspect on this equation, You have to appreciate that I am not including the state symbols, the gas, the aqueous, the solids, and all those things, because we are just trying to illustrate the equations. Okay, but it is important to include them. Okay, if you check on the left side, we have Cl2, that is 2 chlorine, and on the right side we have Cl. Here we have Cl, it means Cl, we have 2, it's balanced. So for chlorine it is balanced. Then now from there, the other elements that we have is oxygen. If you can see, we have ClO3. So we have O3 on this side of the equation, but on this side we don't have oxygen. And remember, according to that, we have to add water molecules to balance. So we have to add H2O, but we have 3 oxygen. It means our H2O should be 3. So we have to add 3 H2O so that we have 3 water molecules on this side, and we have 3 water molecules on this side. So in terms of oxygen, it is now balanced. But now, because of the introduction of H2O, we now have H+. So the equation is not balanced in terms of H+, so we need to balance it in terms of H+, and we have mentioned that to balance H+, we have to add H+ on the side that does not have H+. So for this side, we have 3 times 2, which is 6H. It means the other side will require plus 6H plus. So we have 6H on this side, we have 6H on this side. The elements, they are balanced. It means the equation is now balanced in terms of the elements. But unfortunately, in terms of the charges, we also have to check. This side, we have 0 charge for Cl2, 0 charge for 3H2O. But when we check on this one, we have C chlorate with a minus, which means we have minus 1 charge. And here we also have Cl with a minus, and we have C6H plus with 6H plus, which means 6 positive charges plus 2 negative charges. This is like minus 1 plus minus 1 plus 6. It gives us a total of plus 4. So the charges on this side is positive 4, which means we have more positive charges on this side, so we will have to add electrons. How many of them? 4 electrons. 4 electrons. So if we add 4 electrons plus the plus the positive 4, it becomes 0. Then the charge will be 0. And on this side, we also have a charge of 0. It means now our equation is balanced. So this is basically how you balance the redox reactions. And you will try to attempt this equation and this equation, and I think I also have some more equations for you to balance, and we'll do it in the next minutes remaining. Let's see here on our balance the following equations. I think we have got 5 more equations for you to balance, and I think there are some answers to those on the slides. You can see the answers, they are available, and that's basically on balancing chemical equations. And I think for now we have discussed enough for today, and allow me to give you this chance to ask any questions, to present any comments. You can raise your hand and say something, or you can put it on the chat box. This is your time. I'll give you 2 minutes so that you remain with 15 minutes to attempt those examples before the end of our discussion. So for now, I'll give you the floor to ask questions. You can ask questions, you can type your question on the chat box, you can raise your hand and unmute yourself and ask the question.